all fine. Okay, yeah, so now it's recording. So we're going to walk through this AI security program that has a lot of modules. It has more than 20 modules. And as you can see, it starts from the AI and ML security, then AI models, prompt engineering, forensics, and continue like this. Then securing the system itself, prompt security, AI supply chain security, and data poisoning. And that's the end of the pass. So let's if you are logged in, let's go to the first one that is AI and ML security threats. Let's open this and go directly to task 2. But I'm not going to walk through this text here because that's going to be difficult to follow. Instead, I summarize them here so we can see it easier and follow it better. Let me also make sure that I minimize this. Yes. Now you can see the slides, right?
Sorry, sir. What's the name of the room?
Oh, yeah. The name of the room is AI and ML security threats.
Oh, thank you.
Yes. But we're going to take first a bit of discussion and then we get back to the rooms. Because I'm not planning to, of course, read from the text there. That's going to be boring and you can do it yourself too. But let's make it a bit more discussion oriented. So you already know the impact of AI. No need to really talk about it more. And of course, it's been used in every industry today, in a way or other. So what I'm going to talk about in this program is mainly about how AI itself can be insecure. For example, if the model been trained, how there can be vulnerability within the model, or how data can be poisoned, for example, the data that you are using for training your machine learning. And finally, how AI actually can help the attackers to make it easier for them and faster to develop a malware or a virus and Trojan, uh, probably even without that much knowledge of security itself. So even if there is like a novice hacker, they have much more power today. But at the same time, it's going to be the power for the defender as well, which is kind of like a double-edged sword, as we can see. But artificial intelligence is, let me just draw something here to make it easier when we talk about it. If I draw, yeah, sorry, a circle. Yeah, so if I do the circle thing here, maybe like this. Yeah, sorry, it's not giving color. Yeah, you don't see any color, right?
No color.
Yeah, it's kind of weird. Like, yeah, okay. Now I see it. So if I want to categorize it, I would put this circle, the big circle, to be the artificial intelligence, which means just a broad field of machines that are simulating the human behavior. And it dates back already to 80 years ago. And within AI, we have another category that is called ML or machine learning. So I put it like this, and this is going to be my ML. And ML going to be a subfield where computers learn from data without being explicitly programmed. Now, within ML or machine learning, we have another category that is called deep learning that we have discussed it before too. I call it DL or deep learning. Now, this DL or deep learning has other classes, for example, LLM or large language models, or for example, generative AI or Gen AI. So this is how they are categorized, and you see that how they are subset of each other. Any question that you might have now?
No, no.
Okay, okay, great. So when it comes to the model development, we have a life cycle here. First of all, of course, we are defining our problem. What is the problem that we are trying to solve? Like, can be an emails that our employees are receiving, and they might be phishing or they might be a spam. Or what else could be? It could be an attachment that can be for a file that is shared within the employee's network, and that can be again a virus or a Trojan. I want you to think about it like where else within the security specifically, where the ML can be used, like what type of problem we can use within the security to make the life easier or do the task more efficient than what we are doing right now. Can you think of any? I make one more example. For let's say if we have the SOC team that they are analyzing the threats. So there are going to be a lot of let's say logs that they are receiving, and it's very hard to walk through all this type of logs and understand which one is really a legitimate warning, or some of them can be a false alarm. So that can be one very good applications. Since we don't need to spend like hours and hours walking through a lot of logs and figuring out which one is malicious and which one is not malicious, right? What else can you think of? Let's say I put another example. Let's say you are a security analyst and you want to update your firewall to make sure that if there is a malicious traffic is coming, you want to block it more efficiently. So you are using AI for making sure that your model or the template for your firewall is properly custom configured, right? So if there isn't any inbound traffic coming from a specific IP address, you may want to block it. Or if there is a telnet request is coming, you may want to block it. So these are lots of things that you can actually decide based on the trend that you're seeing out there. And there are many other examples. So if you come up with any others, just feel free to share. After we define the problem, we want to prepare our data. Again, we go to websites like Kaggle, or we go to Hugging Face or GitHub, and we download a database that is relevant to the problem that we are solving. And there are a lot of this open source data. Sometimes also you may want to have to pay a little bit, but it's easy quite to get access to the data. And then you want to do the feature engineering, which means that what type of features are important within this data. Let's say if I am looking at the spam mails, the source IP address might be something important, or the source port might be important, or the attachment might be important. So I'm deciding what type of features within that email is important. And based on that, I decide to keep them or remove them from my data set. Next, I start the training, which means that I choose an algorithm, and we know that we have tons of different categories of algorithms, but broadly we can categorize them as, sorry, keep getting issue here. Yeah. So we can put them as supervised learning, that is like a data that has label. So we already know which one is malicious, which one is not malicious. And the second category that we have is unsupervised. That means that the data has no label. We have a bunch of text, but we try to find some patterns into that text. Third category can be semi-supervised, which means that some of them might be labeled, sorry, I said summarized, semi-supervised. Anyway, that disappeared. Semi-supervised, and finally, the last category that's going to be reinforcement learning. And reinforcement learning can be used for, let's say, training your robot for doing a specific task, and many other things that, of course, we can do and we'll see later. And finally, after that, you do evaluation, which you want to see how good is your model, how accurate it is. So is it 99% of the time correct, or it's 50% of the times correct? And after you are sure that the model is performing good, let's say, for example, had an accuracy more than 90%, you are deploying this model. So it can effectively be on your network and can check all the emails for any phishing content. But how ML thinks, we have like three components. First of all is the precision decision process, which we gives again a bunch of data, let's say millions labeled data. And based on that, we see some of them are malicious, some of them are not malicious. And after that, we give some data that the model has not seen before. And now we ask the model, is this malicious or not malicious? And based on that, the model make the decision. And then we have the error function that we want to see how much, how many percentage of the time the model says that an email is phishing, but actually is not phishing, or how many times a model says an email is not phishing, but actually it is a phishing. And then we want to optimize it, which means that we want to improve our accuracy of the model to make sure that we detect as much as possible correctly. And this is the categories that already I walk you through. Now, when it comes to the deep learning network or deep neural networks, so the way that it works, we have three layers here, three category of layers. First of all, we have our input layer. I put it like this. And now we have then our hidden layer. And finally, we have our output layer. Let's say this is a classification problem. So we do that. So this input come and get passed to the second layer, that is the hidden layer. And let me do it like this. And then finally, these are all passed to the last layer, that is the output layer. And we make a decision, for example, malicious or not malicious. So I put here yes or no. Now each layer is doing different tasks. For example, one layer might try to let's say look at the edges of the image if you are providing an image as input, or the other layer might look at the corners. So just know that, of course, the more layer you add, the more complexity you're adding, and also model becomes more capable in finding uh, mm, more complex features. Any questions so far?
And it is more secure when we have.
No, that's actually a good question. It doesn't make it more secure, and sometimes even make it worse. Because we know that the higher complexity, actually, the worse in terms of security. Because then you don't know exactly what the hidden layer are doing. Let's say if you have 500 layers, it is very, very difficult to understand what layer 250 exactly is doing. And if someone, an attacker, try to manipulate that layer 250, it's very difficult to figure out that what exactly they changed in your model.
Yeah.
So know that, of course, I want you to have this in mind, that complexity is actually something that usually makes security more complicated as well, and more difficult because it becomes a black box. So we don't understand really how the model is working. But it doesn't make it more secure, but it makes it better in predicting and better in finding an email is phishing or not phishing. So there is a trade-off there, because also as you increase the complexity of your model, which means that as you increase more and more layer to your model, it means that you need more processing time for training your neural network, which means that instead of 1 day, it might take you 3 days. So that becomes a bit also hard, because it's gonna cost you more, and also more time for getting a result, which is not really always good. Sometimes you want it. I mean, if you got an email, you cannot wait for a long time. You have to get the response right away. And also, if you want to deploy a model, you have to do it quite fast. You cannot wait for some months to finish that.
So what's the benefit of the complexity?
The complexity is like, let me put it this way. Let's compare a child that is like 2 years old to an adult that is, let's say, 30 years old. So the way that their brains is working is very different, right? I mean, 2 years old doesn't understand a lot of inputs, a lot of data that is coming from the sensory or from visual and auditory. Some of it they understand. For example, okay, this is a sound of water. This picture means this, right? But some of them they don't understand. Let's say if you show an abstract art to a child, they don't understand really what is the meaning behind it because their brain is not yet that developed. But when you show the same abstract art to an adult, probably they can extract a lot of feature out of it. They can explain to you, I think this means something related to nature.
Yeah.
So the more complexity you add, the model becomes more capable of finding some features that might help you for better accuracy.
Okay. Better training, we can say.
Yeah. You see, for example, if you have a small scale model, like in a small neural network that is trained only with very small level of shallow, we call it, like let's say with two hidden layers, they might be able to find out when there is an attachment in your email, but they might not be understand when there are some spelling errors in the email or when there is a malicious URL in the email. Okay, so there are some things that they miss, the model will miss. But the more layers you're adding, the more model become capable of finding those subtle differences and subtle malicious behavior in your email. For example, the model when becomes deep, they might understand that, oh, there is some like mistakes in the context of the email, which means that probably is being done by an attacker, or maybe the sender IP address is malicious, or maybe uh, there is a sense of urgency in the email that they try to encourage you to open this email or click on the link. So that's the difference. Okay, let me just delete here. So when it comes to large language model, so what is our goal is actually is for predicting text and for responding to text, which is like when you provide a prompt in, let's say, ChatGPT or Gemini or any other AI model. So you are asking a question and you look at your text and try to predict what is going to be the related answer because they've already seen like millions of lines of codes. They have seen a lot of books, a lot of articles. So based on the question that you're asking, they can figure out what is the next response that should come after this question. So this is again like the core idea behind the large language model is just to predict the next word in the sequence based on the probability. For example, if you say for breakfast, I would love to have bread with, and then you don't complete this sentence, the next word probably is going to be bread with egg, right? Or going to be bread with, I don't know, cheese. But it's not going to be, of course, bread with TV. Because you are trying to describe what you're eating, or it's not going to be bread with, I don't know, book. So it's again about predicting based on the sentence that you provided what is going to be the next word in here. So models like GPT-4 are trained on the large, very large databases that would take of course, the humans thousands of years to read because they are got a lot of inputs. For example, websites, what else? Books, blogs, and many other type of information that they have been trained on. And also, what comes the power actually of this large language model is after an invention that is called the transformers. These transformers were introduced in 2017 by Google, and the article that Google published was "Attention is all you need," which means that it allows parallel processing of the word simultaneously using the attention score. But what does this mean? Let me explain that to you. This is very important and very interesting. Let's say I would say here, actually, I can draw here too, but that's fine. I let's say I have a sentence here that says like I like to have let's say egg for breakfast. So if we are using an general model here, we have to look at each word. We call each of these token. Okay, so each of them are one token. Token number one, token number two, token number three, four, five, and etc. So we have this one's given to the model. Then these are given as input to your large language model. And based on that, we do some prediction. For example, if I see I like to have egg, and then after that probably comes breakfast. I mean, something like that. So do you get the idea? Like you have a bunch of word, the model get trained on it, and based on that, it can predict what is going to be your next word. Now, what is the power of transformers? The transformers actually made it possible to do parallel training, which means that I don't need to do sequential training, which means that I don't need to provide the first token, then second token. Instead, I can provide all of them in parallel to my model. And if I do the parallel processing, then I can read the entire page in one instance instead of one word at a time. So that's why these GPUs make this much more powerful, the training. And actually, because of the GPU, we can have large language model that are fast today because they can look at the entire page at one in one picture, like, and then they get trained on it. So that save a lot of time and a lot of time actually, not processing because still we are using huge processing.
You
Any
mean
question?
when we prompt to the, for example, ChatGPT, it just
Yes.
look at once in our prompt, right? Not one by
So
one.
exactly, take it all. It take the whole sentence and then
Mm-hmm.
look at it. How should respond the whole sentence, right? I mean, let's say if you're providing a very large prompt to your AI machine, or let's say GPT or Gemini, it take it all at once, one prompt. Don't look at
Yeah.
it word by word. You look at it all at once,
Mm-hmm.
and based on that decide that okay, how should it respond based on the responses that it has seen before.
Yeah. That's become, the speed has become faster.
Yes, exactly, because if I look at the data one by one, then it becomes
Yeah.
very time consuming, right? And specifically I'm talking more about the efficiency in time, because in the training time, because when you train the large language model, you have to provide them, let's say, millions of articles and books.
Yeah. Yes.
So that is impossible if you're gonna do it word by word, right?
Yeah. Yeah.
Now is actually very interesting because the same concept happened for the generative AI. Large language model are used for the text generation, and generative AI is mainly used also for other types, like you can generate a video, image. So these are done the same. Like for example, they provide the entire video, and then they have seen a lot of this type of videos, and then they can generate similar videos for you based on the request that you have. Let's say you describe a text like I want a person that is walking in the fall in the park in the city center next to the river, and they, since they have been trained on such things before, they can generate quite similar responses for you.
And the complexity related to this, how amount of data that the AI is given is related to the layer of the model or not?
Yeah, right. I mean, of course, the higher the deeper the model, or the more hidden layer you have, the more accurate responses you're gonna get. You see, today is actually the models that are trained, let's say for GPT-4 or for Gemini, the latest model, like Nano Banana that is generating images and videos. They have like billions of neurons. So imagine like billions of neurons. So that's actually of the scale of human brain.
Yeah.
That much neuron they have. That is how they can figure out the complex structure, and they can predict how to respond based on the complex queries or prompt that you're asking, because they have a lot of layers that they pass through it, and they better understand, fix their error until they make something that is close to what you ask for. But we're going to talk about it later, but in different course, because here our purpose is more security, not the learning of the artificial intelligence. But it's a very nice conversation, because we have to understand the model first before we can find the vulnerability. But the dark side of AI, we can have prompt injection. You have seen it before too, that we done it with Gandalf. And that is when you ask a question and you ask the AI chatbot to gives you a secret. And the other one is data poisoning, which means that you can poison the data set that is used for training. And in that case, the model will figure out the output or predict the output, but wrong. For example, if you remember, I mentioned this before too, that we call it adversarial machine learning. If you are interested in that topic, is a very interesting topic actually. It's called adversarial machine learning. So what it does actually is, like, if you have uh, tons of road sign, like let's say a stop sign, yield sign for the road traffic. And some people, the researcher, have been able to show if there is a specific stickers that are placed on those stop sign, the autonomous car might interpret them in the wrong way. And they might think that that's not a stop sign, and that's, for example, a yield sign. So they poison the data. Does that make sense? Or the other one is that I give you, let's say you are using a data that you downloaded from Kaggle or from GitHub, and you're training your model on it, and I have some wrong labels on it. For example, I give the model a malicious email, and I tell the model that this is not malicious. Okay, I label it wrong. So the model believes that, because model is relying on my training data and the label that I provide. So model in the future think that if this type of thing is included within an email, that is not phishing, although that is wrong. So it's very important that we make sure that the data that we are using are actually clean. Otherwise, we might have malicious data, and we are training a model that the model itself is malicious.
The attacker can use this AI.
Exactly. So instead of helping you, that is actually distracting you, because before using the model, probably you thought 50% chance is malicious, but now with the model, it tells you 100% is not malicious, but it is malicious. So the same happened for, let's say, if you have an application that is detecting cancer, and someone did some malicious and poisoning the data, and they provide some images, MRI images, and they said if the image has this specific things, this is not cancer. Also, this is cancer. So, and if you are relying on the output of those model, then you are putting your patient at risk, because they don't know that they have cancer, but they have cancer, right? And what else can be? And you can imagine, like, in any place that you are using AI, the risk is there. And if you are using more specifically machine learning, the risk is there, because the data itself might be malicious. So you have to again be careful that the data is clean. And how to make sure, we usually first of all try to download it from a source that is legitimate. I mean, if you are downloading from GitHub and you see that there is a source that nobody downloaded before, nobody mentioned it before, it's harder to trust it than a source that is published by MIT, for example, right? So you have to be careful. What is your input? Also, we say, like, of course, they always say in machine learning that the garbage in, garbage out. If your data is garbage, the output is going to be garbage too. And the other one is actually called model theft, which means that let's say you are working for a security firm and you have developed an AI model that finding all the malicious emails, and you are selling the software to people. But what if actually they can figure out what is the specific model that you're using? Then they can use it and they get it for free, right? Or what if you have developed a model that can generate images very high quality? If people can figure out what is the model that you are using by asking questions and querying your model, then they can figure out what is the specific neurons and weights that you are using. So then you lose your business because your business was relying on that model and now people have it already. So you go out of business. So this is the other thing to have in mind. And next one is privacy issue and privacy leakage. And you know already that if you have trained a model that you used medical images, and those medical images have usually patient information on them. So model has learned some information that were supposed to be protected, right? Or they are personally identifiable information or PII. So if a user is able to interact with it, they might be able to ask some question about the patient itself instead of the image, which is again dangerous because they can extract the patient information. And on the other hand, we talked about the vulnerabilities in AI model, but there can be some attacks that can be enhanced by AI too, like automated malware. So again, you just ask Gemini or ChatGPT, give me a code for a malware that is running on Windows 11 on this specific architecture, and you get it right away. I mean, sometimes it might say like, sorry, I cannot do that, but then you try to manipulate. For example, you say I need it for education, or this is a lab that I'm doing. There are lots of technique that you can actually bypass it, so it's not a big deal. And deepfakes, of course, are the other problem because deepfakes can create social engineering attacks and phishing emails. Today, you have seen a lot of videos that someone famous is talking about something that they never talked about because they generated that video and that looks exactly like that person. And finally, you can do some advanced phishing because like in the past, a lot of phishing attacks they had some spelling issues and those type of things. But with AI, you can make sure that your English is perfect. You can make it more looking real, so people trust it easier. So IBM has shown that companies who are using AI, they are able to save $2.2 million per breach, which is pretty significant considering the fact that the average cost of a breach is like $4.5 million. So you can reduce your cost significantly by using AI. And of course, you have to use AI, but also today we have to just make sure that we are using it properly and in a secure way. And also, IBM report shown that it reduces the time to identify a threat 108 days. So it means that if you without AI you could find an attack in 108 days later, you can find it today with AI, which is very nice. Because in 4 months already you have lost a lot of data, so that's too late. So of course AI can be used for analysis. You're analyzing an email, a log, and you can predict the stuff like, for example, when to block a mail, when to not to block it. You can also ask AI to summarize it for you. I have this log, summarize it for me and tell me if there is any recommendation there. But again, we have to make sure that we don't provide like the logs without masking, because the logs have sensitive information. So if you just give the logs without redacting or without masking the sensitive information, then that information gonna be stored in AI, so other people might be able to extract it. And finally, AI is being used for investigation for people who are working as cybersecurity incident responder or working as digital forensic. They can use it, of course, for make finding the threats much faster. So very interesting thing that I want you to have a takeaway from this session is that only 24% of generative AI initiatives are currently secure, which means that 76% actually their model is not secure. They have some sort of issue. It can be related to prompt engineering, to data leakage, and some other vulnerabilities. So still, you see that majority of the companies actually, although they are using AI, but they're not using AI in a secure way. But how you can make it secure? First of all, you want to make sure that you have some access control in place. Who have access to your AI system? What they can do with that? So you see, when you go to the AI chatbot and ask for it, they might say you are not administrator. But do you have enough guardrails so the person is not able to manipulate the model that they think that you are really administrator? And data protection, you want to make sure that your data is encrypted. And if you provide data to the machine learning model, you want to make sure that, again, you remove the sensitive information. And you have to follow some standards, including MITRE Atlas and ISO 27090 that are used for as framework. I'm going to show you quickly here the Atlas one. Does it look familiar to you? I
Yes,
think you
we've
should.
seen first of the semester, we've seen this.
Exactly.
Yeah.
That's MITRE ATT&CK. Do you remember MITRE ATT&CK framework that was exactly the same? This is called MITRE Atlas, not MITRE ATT&CK. You see, it has all the stages, but this time for AI. That like active reconnaissance, gathering the RAG index targets, search repository, and let's AI supply chain component, and many others. We should talk about them more and more gradually, so you feel comfortable about how we can detect each of them. And there is also some tools that have been developed for monitoring the AI system. Like, for example, let's say this called SHAP and LIME. These are actually used for understanding the model behavior. Because if you don't understand the behavior of a model, you cannot deploy it because you don't know exactly how they're gonna behave. So there are some links, for example, Geeks for Geeks, that you can search about it more and explain to you how you can even install them and how you can use them to understand the behavior of the model better for both SHAP and LIME. But we can, of course, have a separate session and check it together. Any thought before we go to the TryHackMe?
So some organizations that have a sensitive data, like military, are
Yes,
not using AI.
they are actually using AI, but they are making sure that their AI is not on the cloud and is you know that you can have actually AI installed locally on your machine, so you don't share the data with anyone else. You know, you can clone even ChatGPT, for example, on your PC, so you don't share data with other people, right?
Yes.
So they usually have their own AI models, which is secure, and also they don't share the data with anyone else. And also they have checked that they've been trained on the healthy data, not poison data. So with that, they make sure that is okay and they can safely use it. There's no problem. You see, it becomes a problem that when AI can create issue, first when it's sharing data with other people. If I'm using Gemini, if I'm using ChatGPT, I'm sharing my data with this system providers, right? With this AI
Yeah.
providers.
Mm-hmm. Yes.
So although they might claim that they don't have access to your data, but still there is a risk because you don't know, and somebody might actually get access to the backend, and it's a store actually. You see, if you go to the history of your ChatGPT or Gemini, your chat is already
Yes.
stored there, right? And these are also stored on the backend on the cloud, which means that if someone can breach that, they can access also to your queries. And sometimes this query might be sensitive information. So this is the first problem. And the second problem is that how the model is trained. Was it trained on good data or was it trained on poison data? So you have to ask these questions before you can trust it for, let's say, a very sensitive environment. Like, let's say if there is a doctor, let's say if there is a doctor that in the hospital and whenever they see an MRI, they just post it on the Gemini. Of course, that's a very very bad behavior because that's already they are putting personally identifiable information on the internet, right? So they are violating HIPAA right now. So that's a thing to have in mind. Or any other firm as well. Let's say if they are in finance and in a bank and they are searching, putting a screenshot into Gemini and the account number is there, they already provided the account number in a public cloud. So, and there's been a lot of source of breach actually that publicly this type of conversation been exposed on the internet and people have seen chat of other people in the entire conversation.
And there's no security right now for this kind of
There is
problem.
actually is not. I don't say like is really not is always public. There are some measures that you can make sure that reduce the threat. For example, on the AI provider, always give you the option to not to use my data for training, right? And but I'm saying like is still there is a level of uncertainty because you are relying on a third party for protecting your data, but you're not sure about it.
Okay.
Yeah. Okay, so let's get to the lab and do it. It's quite fun. First, let's answer the first question on the building blocks of AI. So let's go directly to the question because I already walked you through the text. So what category of machine learning combines both labeled data and unlabeled data? Let's go to our slides. Here, look at this slide. So which one I said like it combines both label and this is label data because already each data comes with the label. This comes without label. And this one comes with some of it gonna be labeled, some of it gonna be unlabeled. So that is called semi-supervised. So let's put it semi-supervised learning. What is the first layer in neural network that handles the incoming data? Let's get back here. Or better to show you here on this text here. What is the answer for that? Look at it, we have three layers: input layer, hidden layers, and output layer. Input layer, for example, is a bunch of text, let's say a lot of emails. Output layers is a decision: is the email malicious or not malicious? And this hidden layers are in charge of finding relationship, finding features, and finding correlation between data and etc. So the input is the one that is in charge of the
raw data.
Yes, exactly, raw data. So that is input. Sorry, it's called input layer, not input data. Now you answer this one. Which learning method does not require human labeled data and can extract feature from raw input? This one I didn't talk about, but actually this is called the deep learning that I talk about. You see, like if you remember, I draw different models that we have. And deep learning was the one that we have a lot of layers and input and output. And actually, you can provide the raw data and it will learn how to categorize them and classify them. So deep learning can do that for you. So this is deep learning. What are the weighted connection between nodes in a neural network meant to simulate the human behavior? Let's see this one.
Wow.
So we're going to find out what is the one that is in charge of this connection. So it should be somewhere here. Let's see. Let me get back here. I'm going to search for one thing, neuron model. Doesn't show anyway here. But what you're looking for is synapse.
Synapse, yeah.
Yeah. But there was something synapses. It is actually. Okay, now we talked about LLM. Let's go. You see, again, I showed you already the example, but also in TryHackMe says, ever have that feeling where you're not sure if you are awake or? So the model is going to predict what is the next word, right? Can the next word be egg? No, right? So here, based on this, we'll predict what is going to be the next letter, the next word. Is going to be dreaming, 65% chance. 15% is going to be asleep. 8% going to be hallucinating. 5% alive. And it will list all the possible letters and gives each of them all the possible words and give each of them a weight or a percentage. So here it will choose dreaming because that has the highest possibility. So let's go to and this is the category that I showed you. So AI is the top category. Then under AI, we have ML or machine learning, then deep learning. And under deep learning, we have generative AI and LLM or large language models. Generative AI is that is mainly used for, let's say, music, image, videos, and LLMs that are mainly used for text. So what type of AI model enabled major advancement in ChatGPT and similar tools? So I told you that there was an invention. Let me get back there. Here. This invention made it possible to develop ChatGPT and other advanced models. So that was called transformer. But here the answer is like what type of AI model? We're not asking about a specific neural network. So it's going to be the large language models. And do you know again why we call them large language models? First of all, these are like deep learning network, meaning these are large models, large networks, right? And they are dealing with the language, with text, with the way that we they are related to NLP or natural language processing, if you heard that. So that's why they are dealing with the language processing, and they are large models. What is the first training stage when an LLM processes massive amount of data? So, okay, first of all, we start actually with, they call it pre-training. Sometimes you might also hear the term pre-processing. So both are the same. So which means that you have to clean your data, right? Sometimes you have repetitive data, you want to get rid of that. Also, sometimes you have noisy data, you may want to make it cleaner. What type of neural network introduced by Google that powers the LLMs? This is the answer that we talked about before. That is what?
Transformer?
Yes, transformers, yes. Transformer enabled the large language models. Any questions so far? These are quite easy. Just to understand that, okay, what are the component of a large language model and that. Now let's get to more interesting part that is AI security threats. We talked about the type of threat that can exist. What framework was developed by MITRE to guide the understanding of AI specific cyber threats?
Atlas?
Yes, exactly. That is Atlas. And what type of attack involves cloning or copying an AI model by interacting with its API? Let's get back to the threats here.
Stealing? Thief?
Yeah, that was model theft, right?
Yeah.
Yes. So you are trying to get the structure of a model or the secret sauce of a model. So that was the model theft. And what generative AI technique can replicate a person's voice? You already know that? Here, what it
Deepfake.
says? Deep fake, exactly. What common social engineering attack has become harder to detect due to AI generated fluent messages? So we talked about it. So what type of attack has been harder to detect?
Phishing.
Phishing, exactly, phishing. Right now, in the defensive side, also we talked about the that it can help us to analyze the logs. It can help us to predict if an email is really phishing or not. Can help us to summarize, so we don't need to read through hundreds of pages, really. And also ability to investigate if there is a breach. So also we can use model monitoring that I told you there are two techniques that are called SHAP and LIME, again, to understand better the behavior of a model. Because you see, this is actually very important. Let me explain quickly. The models actually, for many reasons, their quality and their accuracy drops after some months. So if you train your model once, it doesn't mean that you're good for the next 100 years. You have to retrain it, for example, every 6 months. Why is that for? Because there might be new type of attacks that are happening, right? Or there might be some new type of defenses that are available now. So you have to make sure that you update your model, otherwise it accuracy gonna decrease over time. So according to IBM, how many days faster does AI help to identify and contain a breach? Let's get back here. Here you have seen it. So how many days?
108.
Yeah, it is also 108 days. Here we can also find it. It's on the text because I summarized there. So it's 108. What cybersecurity task benefits from AI helping to imagine attacker behavior and what they might consider? Sorry, what may not consider. So here we didn't talk about this part. Let me see. Oops, sorry, it's going to refresh it, which is fine. So here you see like threat hunting. Let me get back a little bit. So it says LLM can provide queries to run which gives output helpful in the diagnosis of the issue. These chatbots are also helpful in the task involving human imagination. It does have the limitation, of course. For example, we can think about threat hunting. When you want to find a threat that might exist in your network, but you don't know about it, right? So AI can help you with that. So this is going to be threat hunting. And explainability tools such as SHAP and Lime help with what we just saw it here, model monitoring, right? So can a flag when the performance drops actually, so you can retrain the model. It's going to be model monitoring. Great. Now let's do this practical part. Let's open the agent. You can ask any question here, but I'm going to ask some specific question. First, in terms of log analysis, it's like, of course, ChatGPT or Gemini. We're going to ask it some question. Here, let's copy this question here. Says here's a log line, April 22nd, Ubuntu SSH daemon, failed password for invalid user admin. And we want to ask the model, can you explain what is happening in this log entry? Let's do it. I think I didn't copy the, let me copy here. Yeah, I did, sorry. So here it says like, what is this? Look at your response. So it's much more cleaner, right? It's much more structured. If you look at it like this line, it is taking you a bit of time to figuring out the time and etc. But this gonna do it for you in different line by line, explain what is the host, what is the service.
Oh, yes.
What is the service ID, and tells you what happened exactly. Invalid user means that the account does not exist on the system. And also give you a bit of interpretation. Someone from this IP attempted to log in. So of course, this is much easier to understand than looking at this line here. And now imagine that you don't have one line, you have thousands of lines. This is becoming much more difficult. What you can do, you can provide it to your machine learning model or large language model and ask it like summarize it. What is the common threat in terms of the attacks that we are getting, right? So that's going to definitely help. And phishing email detection. You see, if you look at this email, it might take us a while to figure out what is wrong with it and what is not. But I can quickly copy this email and ask here, like, is this email phishing? And I wait for it. Usually it's faster, it's too much thinking, but anyway. Anyway, I have this response also generated above. It's failed because I asked before to, that's fine. So you got a response on your end or no?
No,
What does this say?
just loading.
Okay, so while that
This
loads,
email is highly suspicious
yeah, why?
and likely phishing attempts several because so many reasons.
Yeah, first of all, it says suspicious sender address. The address claims to be Microsoft 365, but it's actually coming from M1 Microsoft.
It's for second one for me. Okay.
Yeah, the other one, urgent language, that says you have only
Exactly.
12 hours. Suspicious link. Generic greetings, doesn't tell you exactly your name, just said their user. unusual requests is not like they ask you like this to verify their account. And you see, this is much better because a human might miss some of this detail. For example, actually, there are a lot of humans that miss it when there is a email coming from M1 Microsoft or is coming from Microsoft. They might see both the same because we are looking very quick and we are seeing what we want to see.
Yeah, exactly.
So yeah, this is definitely much better for in terms of this type of attacks. And now we can do also threat hunting. For example, can you suggest 3 realistic threat hunting scenario that a cybersecurity analyst should investigate? So let's search about that. So yeah, here told me detection of unusual exfiltration, identifying lateral movement, or detection of persistent mechanism. You're already familiar with all of them. We have discussed it before too, but you can have a look and see if something new come up.
I got 3.
Yeah, also because we asking here, but you see, like for example, says like they might use DNS tunneling, or they might use encrypted channels, which is of course something make it harder to detect, right? Or they might use PowerShell, for example, for running a command. So they are living off the land. So you don't suspect if PowerShell is running. Or they might use persistent mechanism like they change their registry. I'll talk more about registry later next semester, but also that's actually a very effective way to bypass the security. Or we can use it for content generation. Let's say you want to configure a firewall and you don't know how to configure it properly. So you can ask AI that write a regex pattern that would match failed SSH. So this make it much easier for me. Even I don't need to know specifically how to write this regex. So you see this is done very nicely. So I just can copy it and put it in my configuration of my firewall or any other security mechanism that I have.
How much we can trust them?
Okay, that's actually a good one. So you should have, of course, the knowledge of making sure that actually, because of course, if you bring someone that they don't know security at all and then they just copy and paste it, that's a disaster. But as long as someone is familiar generally with, let's say, what is a regex and can double check it, that's really okay because then we don't need to spend a lot of time for writing. We can spend more time on checking and more type of work that needs to be done in the company. Because a lot of companies, of course, also they don't have like let's say 20 security analysts. They have like 2 analysts, for example. So they are very overwhelmed with a lot of tasks. So that's make it easier at least to do their job. And let's find the flag. Here, the flag gonna be the answer for this T3 question. What are the 3 values for DNS over HTTPS port, Sinfulot timeout, and Windows ephemeral port range size? So let's copy that too anyway, now that we are using AI. So we put here THM. What is the first answer? So DNS is done over HTTPS, that is 443. So here we put 443. Now what is the flood timeout? I wait for you to answer. You can look
120 seconds.
and look at the answer that I've got here, the scene flood timeout.
60.
Yes, it is 60. It says sync float timeout of common value is 60, but it's configurable, which means that you can change it. So here is 60. And finally, what is the ephemeral port range size? Let's go down here. We're looking at the total ephemeral ports available. That is going to be
60,000.
exactly 60,000.
384.
Yes, exactly. Thank you. Yes, so let me stop sharing here because we're done and then we can talk more together. And also I stop recording.